Hi guys, and welcome to a new video. This is going to be my 100 subscriber special, so thank you all for subscribing, I really appreciate it. And let's carry on with the video. So, in this video I'm going to be making some Piranha solution. Now, a lot of people have done this on YouTube already, but I have not, so I want to do it. Piranha solution, also known as pre-oxy monosulfuric acid. Pre-oxy meaning there's 5 oxygens, and then there's sulfuric acid with an extra oxygen basically. There it is there. Pre-oxy monosulfuric acid, H2SO5, and normal sulfuric acid is H2SO4. This is also known as corrosive acid, the person who discovered it. So, corrosive acid is one of the strongest oxidants we know. One of them. It is normally used to etch circuit boards, and it's also used to clean organic stains, normally in chemical glass, where I've used it quite often to remove stains that just nothing else remove, and it works wonders. Unfortunately, corrosive acid or pre-oxy monosulfuric acid is quite explosive. Now, we're going to be making a relative small quantity of it, and it's going to be in a solution that is going to be cooled and so forth. This is a very, very dangerous mixture, and it's to be a last resort when trying to remove stains. Now, normally you want to add the hydrogen peroxide, which should be around 30% hydrogen peroxide. My hydrogen peroxide is 50%, and making it 50% can actually be quite explosive, so I will not be using 50% hydrogen peroxide. I'll be diluting mine with 10 milliliters of water. Currently, I do not know the exact concentration of my hydrogen peroxide. I did buy it at 50%, but it's been in its container for a while. They do add stabilizers, but hydrogen peroxide decomposes on its own into oxygen gas and water, so the concentration will not be 50%, it should be a lot lower. But I'll still be adding the 10 milliliters of water for safety, as the 30% concentration is fine, and even a little bit less is okay. Corrosive acid is normally made in different parts, different mixtures they use. I'm going to be using a 3-to-1 mixture, 3 parts sulfuric acid, 1 part hydrogen peroxide, but there's also mixtures of 4-to-1 or even 7-to-1. To make corrosive acids, there's different mixtures you can use. I'm going to be using a 3-to-1, 3 parts sulfuric acid, 1 part hydrogen peroxide, or some people would make a 4-to-1 ratio or a 7-to-1. You do not want to add the hydrogen peroxide really fast, as I mentioned, because this can bring the whole solution to a boil and possibly explosive. And a boiling solution of a mixture of sulfuric acid and hydrogen peroxide, which will also contain corrosive acid, is not very fun to deal with. It's very dangerous, and it could be explosive. And sulfuric acid boils at 337 degrees Celsius or 639 Fahrenheit. Sorry, what? We don't use Fahrenheit? But why? I must stop asking silly questions and repeating what the voice is saying in my head. Of course, the addition of hydrogen peroxide would lower the boiling point, but it will be well over 100 degrees Celsius and very dangerous. Now, a lot of the videos will say hot Piranha solution. It is hot, but they didn't make it hot. It's an exothermic reaction that made it really hot. Now, there's some very, very, very important thing to know, that you do not by any means add ethers or any ketones to the corrosive acid, because they can form dangerous peroxides, unstable peroxides that are highly explosive. For example, acetone could create acetone peroxide, and you do not want that. It is crucial that you do keep away from any ketones and ethers. You might be thinking, oh, cool oxidizing solution, let me add some, well, I don't know, some acetone, and then boom, you're dead. So do not add any of those. Very important, you do not add that. Of course, full face shield with goggles or eye protection underneath the face shield. I would use gloves. Even though that you've put hot sulfuric acid onto your glove, it will probably melt the glove, but you'll be keeping it cool, so that won't happen. Lab coat, just really try to be as safe as possible when dealing with the solution. If you're really uncomfortable, you can make it a 7-to-1 ratio, which will make it a little bit less unstable and easier to work with, you could say. Now, and that's it. We can start making the corrosive acid. I will be seeing if different things can dissolve in it: paper, styrofoam cup, cotton swab. And I have pre-chilled the hydrogen peroxide to around minus 15 degrees Celsius, and I'm going to pre-chill the sulfuric acid in the freezer for like 30 minutes or so, just to keep everything cold. I'll be mixing it here into this 100 milliliter flask. I'm very happy that I've ordered these flasks. There's a brand new order that arrived. Let me just show you. Here it is. Now, some of the beakers I already had, just these 2 extra beakers and the 2 1 liters at the back. They are new, and all the flasks. Look at these nice flasks. The funnels, which I'm really happy about, because I've been using these crap plastic funnels and I'm always worried about certain acids reacting with residue left on the plastic, and I'm very happy that I finally got these glass funnels. I've also got a volumetric flask here, 100 milliliters. I will probably use this flask. It's just a very nice flask, and if I ever need it, I have it. I did order bigger watch glasses. Let me just bring this down here. Yeah, so I can... Yeah, the previous one, the hand was only this big, and I didn't know how big they would arrive, so I was a bit disappointed, but now I got some nice big ones. And they're not borosilicate, so I do not want to heat them up too much with any reaction. So yeah, let's begin. Alright, I'll be pouring 75 milliliters of concentrated sulfuric acid. There we go. I'm using the plastic beaker because I want to be accurate with the hydrogen peroxide. I'll pour this into the flask. Very nice. The flask seems pretty accurate, more accurate than beakers at least. Alright, just remember that when measuring out your liquid, do not use the same container that you used for the sulfuric acid, because you'll form the corrosive acid inside the measuring cylinder because you're mixing the two reagents together. I'm going to pour 10 milliliters of water into the measuring graduating cylinder, and then I will pour the rest up until 25 milliliters of my hydrogen peroxide. This is quite cold hydrogen peroxide. There we go. It's not accurate, but it's probably the right concentration as I want. I'll move the hydrogen peroxide into a beaker so I can pipette it easily. I'll start adding the addition of hydrogen peroxide with a pipette. Now, I probably should mention that the paper floor that I'm using to make it look more presentable at least is probably not the best material of choice, as it will dissolve pretty easily. Right, I got a pipette that only goes up to a milliliter, so this might be a bit of a loss, but it's safety. And you can see there's a lot of fumes that come up, and you should gently swirl the flask. Sorry for that. And now I'll start the addition, or continue it. see it's bubbling a lot now. It's up to 70. You want to avoid it going to 100 because there is water in the solution. 98% sulfuric acid and 30% hydrogen peroxide. There's around 32% water altogether, like 2% of the sulfuric acid, and then 70% of the hydrogen peroxide is water. So that's why, one of the main reasons why it's exothermic. It's getting really hot now. When I stir, a lot of bubbles are forming. It's at 80 degrees, so I'm going to let this cool down to around 50 degrees again, and then continue the addition. Moved it to a container of water. This is just normal tap water, but the temperature is around 20 degrees Celsius and it's fully submerged. So the temperature should be decreasing as it is. It was 80, but now it is moving down rapidly actually. And if I stir this, the liquid will start touching the walls of the container and it will just cool down faster. I'm going to continue the addition of the hydrogen peroxide now and drip it onto the thermometer so it runs down slowly. Sorry for the wobbling foam, but I do not have a stand. There we go. This is some nice Piranha solution. Corrosive acid, peroxymonosulfuric acid, whatever you want to call it. Oh, there we go. So it's around 60 degrees Celsius now. Just give it a quick, kind of a rough stir. And I'm gonna, there's about less than a few milliliters left of the hydrogen peroxide, so I'm just gonna pour it straight from the beaker. Because I'm a bit impatient with that small thermometer. Let me just switch hands to the hand with the glove. These are definitely not dishwashing liquid gloves, definitely chemical grade gloves. Add the addition really slowly still. Still very just dropwise. Stop a bit and then give it a stir so it doesn't all collect at the top. Yep, it's still at 50. And that's all the hydrogen peroxide. Give it a small stir. And the solution is now ready. I'll let this cool a bit, but normally it will react with paper a lot quicker when it's hot. And just do a little demonstrations. Right, so the solution's about ready. I will take it out of the cooling bath and just wipe it with some material, get all the water droplets off. And now I'll pour a little bit into this beaker and show you the reaction with cellulose, that's how you pronounce it. Let's make sure that just add a little bit. If there's any organic matter in your beaker, this will dissolve it. Only add a little bit is necessary. I'll put this back in the cooling bath. And now get a piece of paper. I'm just gonna, yeah, that's how I do it. Here's the piece of paper. And I'll just put it in. As you can see, it's busy dissolving the paper. The reaction will get a lot hotter and a little bit more violent as this reaction carries on. It seems pretty tame at the moment, but you'll see. The whole thing submerges will create a lot of CO2 gas, and the black formation you'll see now is the carbon. Paper is gone. a lot of carbon. If you add more solution, it will all convert to CO2 gas and become clear. Now what I'm going to do, I'm going to use the same experiment but with a wet piece of... Alright, I got a damp piece of paper. Now let's put this in. What should happen now is that the piece of paper, added here, is now wet, so the reaction with the sulfuric acid and the corrosive acid will be a lot more, it will get a lot hotter. As you can see, it's actually not much of a difference as I thought it would be, but let's see. There it is, starting to break down the paper. Very nice reaction. Very fast. Very slow apparently. I'll swirl it around. Right, so next time, in the next clip, I'm actually going to remake the solution and make it a bit hotter. And because that seems to have made a cooler effect. Again, you don't want this to be too hot as it's quite unstable, but as you can see, it breaks down the piece of paper like it is nothing. And I'll do that now. Right, so I tried to see if it would work with a styrofoam cup, but it just seems to dissolve styrofoam really slowly. And not as impressive as I thought it would. And I guess that's the styrofoam cup, it just doesn't work as well. I've moved all of it to a large amount of water to dilute it, and I'll let it air out for a decent amount of time. I've added the rest of the corrosive acid into the beaker that contains the orangey red color, and that would probably clear up like this beaker here with the first piece of paper. See, it's busy dissolving, so yeah, we'll do a little bit of a hotter scale, I should say, and see how that goes. Alright, so I've prepared the Piranha solution in the 1 liter beaker here, and yeah, so I got a little bit of acetone in this pipette over here, and you may be asking, well, ChemLab, I thought you said Piranha solution and acetone or any ketone and ester will make a dangerous, unstable peroxide that's highly explosive. Well, you're right. Alright, I'll begin the addition of the hydrogen peroxide slowly. This is very dangerous. Please do not repeat this experiment. Alright, I'll add a wet cotton ball in, a little bit damp, and you guys can see the reaction. And this is when you want a full face gas mask so your eyes don't get burned from the deadly fumes. Anyway, I am going to add a little bit more cotton ball. As you can see, it is boiling. Very hot temperature, yeah, but more cotton ball. Very quickly dissolve. I will now try the styrofoam cup again since it's really hot. Here comes the styrofoam cup. Maybe putting it upside down wasn't the best idea. Look at that dissolve. Dissolving away. It's actually also melting. The melting point of styrofoam, and this is like a really, really hot solution.
temperature is skyrocketing on my thermometer. You see, it's just dissolving. Doesn't even, no problem at all. Look at that. Did you say styrofoam cup? Because I don't know what that is anymore. Look at that. No problem. It's about 120 degrees, moving up quite fast. 130 degrees Celsius. And around 135, moving upwards as I will increase this. So you can see 135 degrees Celsius. And that's Piranha solution for you. Be very careful with this. Imagine this cup on your hand or equally flesh just like this cup. But I do believe this is mostly also melted. Anyway, let's enjoy it again with a little bit of cotton wool. Actually no, let's try it with a piece of paper. Don't mind me. Yep, piece of paper. Quickly dissolves. It's all black. That's the leftover of the cup. Not much effort to dissolve it. I do think most of the cup is it's just melted actually. But some of it is indeed dissolved and turned into carbon and is converted to carbon dioxide gas. There is a lot of sulfuric acid fumes and hydrogen fumes happening there, so please, all safety for the gases, extraction fan, gas mask, eye protection, and so forth. To get rid of the solution, we'll leave it out for a little bit, and then you will just dilute it with a lot of water. Do not add water into the solution. You want to add the solution into a lot of water. It will just make a dilute solution of sulfuric acid, which is a lot better than this. And thank you for watching. This is Piranha solution. Please like and subscribe. And goodbye.